Hello and welcome. So the topic that we are going to talk about is a ping tool, which is going to be a very handy tool for a network engineer or even the system admin. So in the next slide, the agenda is talking about what is the ping tool from the perspective of troubleshoot, from the perspective of network security, and then in the end you have to provide us the assignment. So let's have the next slide, which is talking about the definition of ping or ICMP tool. So it is mentioned that unlike transport protocol, so unlike the TCP or even the UDP, which are what? They are designed to carry data. If you remember, we used to carry HTTP traffic or HTTPS traffic. In case of UDP, we carry what? Video streaming, okay, audio. Okay, so ICMP is not designed to carry data. So while ICMP do have the data section, so although they have the data section, but their purpose is not to wrap and carry protocol like HTTP or DNS. So instead, ICMP is designed as a low-level management protocol tool, okay, for the internet. It carries error messages and implements simple management functions, which we are going to cover later on. So the ping is a command prompt utility used to test the ability of the source computer to reach the specified destination. So let's suppose if we have source computer and we have destination. And if let's suppose they are connected with the switch and they have some kind of IP, let's say this is 192.168.1.1. Similarly, this computer is 192.168.1.2. So I will issue a ping command pinging to the destination 192.168.1.2 and hit enter. If I will get a reply, it means this computer is up and running. Maybe this computer, if in my case, when I was sitting in my um, IT room, which is over here, okay, then we have multiple floors, which have multiple switches and let's suppose wireless access points. These all devices, IP cams. So if one of them is not working, first thing I will do, I will try to issue a ping to those IP cams to check whether the IP cam is physically up and running or no. Okay, so this is very handy too. So available options are there are many, but the one that we are going to discuss are these ones. Okay, and then we have some error messages we need to take a look of. In the next slide, as you can see, on OSI layer, our ICMP reside at which layer? At network layer. Okay. So beside IGMP, IP, and ARP, we have ICMP. So if we'll talk about just like TCP header and UDP header and IPv4 header, we discussed about that. ICMP also has encapsulation. So as you can see, if you take a look of the ICMP packet, you will see the types, the code field, checksum, rest of the header, and data section. So this is for the payload. And this checksum, as it is written that it is a 16-bit field to detect whether the error exists or not. Okay, so this is just to check the error. On the other hand, we have this type and code. And we are going to talk about this type and code in the next slide. Okay, so from the perspective, so first of all, I'm going to show you the type and code. So this is the type field and this is the code field. So, sorry. So this is the type field and this is the message. Okay, so type field is representing, for example, if in a Wireshark, if you will see 0, it means this is echo reply. And opposed to reply, we have request. And if we get the code 8, it means this is a request. Similarly, we have some another code like source quench, destination unreachable, and these all timestamp reply, and these all like time exceeded. So these are all codes, and these are all called ICMP messages. So if I will take you back. Okay, so from the perspective of troubleshoot, so before we troubleshoot, I just want to give you the demo on these specific options that I have already shown you over here. Okay, so let's open the command prompt. First thing first, I just want to give you the scenario first of all. Just a minute. So currently my source, my computer is having the IP 192.168.100.3, which is directly connected to my wireless router, which has the IP 192.168.100. I guess one. I don't know. Let's verify very quickly. So ipconfig/all is the command to verify. So if I'll take a look of my default gateway, so this is the IP. So default gateway is 100.1, and the IP address to my PC is 192.168. Just a minute. So this is showing me the IPv4, and this is the IPv4 address 100.3. Okay. Okay. So this is currently the scenario. So first thing first, I want to ping whether my router is alive or not, or whether it is up and running or not. If I'll do ping 192.168.100.1, and you can see it is giving me reply backs. So TTL it's set for 64. If you remember, we have already talked about TTL. The time is, this is round trip time, by the way, RTT. Means the time it taken from source to reach to the destination and return back. So in 1 millisecond, it is coming back. But on also you also have to take a look of these. As you can see, it sent 4 packets, received 4, and there is 0 lost packets. Similarly, if I will try to ping my Google DNS, hit enter, and you can see the TTL has been changed and the time is much higher, because pinging my router is very near to me. But if I'll try to ping the Google DNS server, that may be sitting far away, so you can imagine the time, how much time it took. But still, it considered to be a very good time. Okay, if I'll type ping minus and then question, it is going to give me the all parameters that I'm going to use. I can use like minus t. Okay, minus t basically is used to ping the specified host until stopped. Then we have minus a resolve host, resolve address to host name. Then we have minus n number of echo requests to send. Okay, so these all options we have, like minus s source address. Okay, and then this ping is for IPv4 address and this for IPv6 address. So let's try this one. So let's suppose if I want to ping minus t to my Google DNS, and you can see it will start keep pinging, but you can observe the timing 139, 138. Okay, and now it is stable again, it went to 139. So if you will see some kind of delay happenings over here or request timeout, it means you are having some internet connectivity issues. It could be related to DNS issues, it could be related to your uh, you know uh, maybe your ISP side, or maybe the cabling issues. Okay, so we are going to discuss these things in a troubleshooting. So this is, you can see, it is giving me 0% loss and send 36 packet and receive 36 packets. Then we have options -a. So if I'll do ping, then question mark. So it is -a is used to resolve the host name. So let's suppose we have one uh, SQL server, database server, or application server which has some kind of DNS name. Okay, because like in my case, my if I will type host name, you can see my computer name is Cyber PC. So it means every computer has some kind of name. But if I try to ping 192.168.100.3, it is not going to give me any kind of definition that what is the name of this computer. So if we are interested to resolve the name, we can use -a 192.168.100.3, and then you can see the internal name that I have given to my computer is host.docker.internal. And by the way, this is I set from the host file. Okay, from host notepad. From there, I just hard coded that name for some reason. Similarly, if I'll try to ping my, let's suppose, ping -n to my router, but you are not going to see, sorry, -a. It is not going to resolve the name of that one. As you can see, it is taking time because it took some time to resolve IP2 DNS. Okay, but didn't work because router does not have any kind of name. Then we have -n. So basically ping -n. And if I will say, for example, this is a number of count. For example, I want to ping to the Google DNS server 10 times, 4.2.2, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So total packets sent 10 and received 10 and lost 0. Okay, so -n option is for that. Then ping minus, if I'll show you, for example, this is for the source address. Let's suppose my computer, just a minute, let me grab my pen. So let's suppose my computer have multiple interface card. One is using for virtual machines, another one is using for some another network interface card. Okay, let's suppose this is the server and it come came up with multiple NIC cards. So currently, if I try to ping my this router, it is going to source from this IP address on this network interface card. But maybe my virtual machine has different IP.10.10.1. Maybe this NIC interface has different IP like 172.168.1.1. Okay, so in that case, we are going to source our packet from this NIC card. So this is the whole idea of having that. So let's add about the. So if I'll try to do IP config, so let's do ping -s. This time I want to make a source as, let's say, make it 172.168.1.1 to the destination to my gateway. And if I hit enter, you can see the general failure, which means that this IP address does not exist at all on my machine. Okay, so it's nowhere near. So that is why transmit failed and general failure. And general failure also happens when network interface card is not available. It is down. Okay, so this is also I'm covering troubleshooting part here as well. So if I will try to source this time from my 192.168.100.3 machine and try to ping, and you can see the reply is coming back. Okay, so let's start over the next slide. So which is talking from the perspective of troubleshooting. And we have already gone through some of the portions. Like we have error reporting messages. When we have 3, it means destination is unreachable. When we have 4, it means source quench. When we have 11, time exceeded. When we have 12, parameter problems, redirections, and these kind of issues. But in case if we have 8 or 0, it means 8 belongs to echo request and 0 belongs to echo reply. Similarly, time step request is 13 or 14. So let's, if I'll take you to the command prompt. For example, if I try to ping, let's say 11, 12, 13, and 14, and you will see different kind of error. Request timed out. Okay. So timeout means the packet has been sent to the destination, but destination is not acknowledged, didn't give us any kind of acknowledge. And as you can see, 100% loss. Okay. If I try to ping 192.168.100, this is my subnet. But I am going to use some random host and hit enter. But this time you will see host unreachable, which means that the the just a minute. So which means that we are on the same network and it is trying to reach to the destination, but destination is not there. Okay. So this is another error. So we have covered destination unreachable and time exceeded also in the same fashion. For example, if I am trying to uh, send the packet in the internet, okay, and my TTL value becomes 0. So this is how I'm going to get back this error saying that TTL time exceeded. Okay, then we have a source quench. Source quench happens when you are trying to reach to the destination and the destination is not aware about my request packet. So basically, uh, there is no flow control or and the congestion control mechanism on the destination end. So this source quench kind of issues happens there. And then if two ICMP have parameter issues, then it is going to give me these kind of errors. And by the way, if you get the error something like this, now we are getting reply from here. Then on the second line, we have request timeout. In a third, we have a reply, then request timeout. Okay. So these kind of things like 2 packet lost, 50% loss. These kind of things happen when there is a DNS resolution issues. And by the way, this could be the cable issues as well. This could be network card issues as well. Okay. And DNS resolution is DNS caching issues. And final, and in case if there is a loop. So you have to look out on it. I hope you get the idea. Okay, so I'm going to end this video over here and I'm going to see you in a Wireshark